Hello viewers, welcome back to our channel Smart Data Learners, a project of data scientist.ca. In our today's project, we will go through some important uh, aspects of SQL language, which is the core, which is the very important part of the data analytics landscape. So let's begin on our today's topic. So in this today's tutorial slash topic, we will cover enterprise data understanding utilizing SQL. And in this tutorial, we will basically use the AdventureWorks data warehouse, a sample database by the Microsoft, and run queries and explain the queries to extract information relating to enterprise data. So let's start. So in the module 1, we will inspect fact table. So in the fact table, inspecting the fact table, we will select the top 10 rows from fact internet sales table. So we'll copy this. Basically, what it says is the select top 10. Static means all from fact internet sales. So let's do that. This is our SQL Server window, and here we will go and copy uh, this code SQL. So as mentioned earlier, that is basically select top 10 static from internet sales. So this is our AdventureWorks data warehouse 2022. So we have already created tutorials on installing this database, but today's focus is on learning SQL for enterprise data understanding. So let's run this query. You see we have top 10 rows, 1 2 3 4 10, and then we have all the columns. You see, if we go to the tables and we'll go to the fact internet sales. So in the fact internet sales, we select top 10 static from fact internet sales, and all the columns. Static means select all the columns. You see, this is a product key, order key, due date key, ship date key, customer key, all the way to ship date. So if we see last is ship date. So that's how we can, that's the basic query for understanding what's in this table. So we have top 10 rows. So the next one is inspection of the dimension tables. We can copy these, select top 10 static from dim customer, dim product, dim date, dim geography. Just copy these. If we run all of at once, we will have different windows showing customers, product, and geography. Let's run that. You see, number one is dim customer. So these are the customer top 10 customers. Then we have a product and after that we have a date key, dim date. And then we have a geography. We can run, if we highlight one and then run, we will only have the customers. Then we can run dim products. We will have top 10 rows of the, and then we can have the top 10 rows of the dim date. So basically these are all tables we have. So we selected from these tables. Okay, the next one is advanced querying and business logic. 2.1 sales bucket classification. So in this, we will classify sales by case, right? So let's go through the SQL language. Select sales order number, sales amount, right? Then we utilize the case statement. When sales amount is greater than 5,000, then high. When sales amount is between 1,000 and 499, then medium value, else low value, and as sales category from fact internet sales. So let's copy that. And we will run this here. So basically what I've, let's see. We can add one more thing, order by sales sales amount. You see now we have the mixed all of these, but we can, if we ordered by sales amount sending, you see we have low values first, and if we do it by descending, we have medium values. So we don't have any advanced, means like there is no amount is greater than 2,000, 5,000, or equal to 5,000. So most of these are 3, 5, 7, 8. So that's for the we basically would utilize the we use the select, simple select statement, and then comma, and then in this comma we use the case statement, and in the case statement we use some greater than is high value, medium, else low, and as, so this is the column name, sales category from fact internet sales, and order by sales amount descending. So let's go to the next one, customer value tier. So here we will select customers based on whether they are how much they spent. If they spent greater than 20,000, then they are VIP, otherwise they are gold. So let's do that. There is another important thing we are using here. So these are all standard. So what we can do is we can lower these 3,000, like those who are greater than 5,000, these are gold, and those who are greater than 3,000, they are VIP. Now let's run that. You see, now we have some VIP and some gold customers. These are the customer key, and this is the total amount spent. And viewers, there's then another important aspect with that is we are using common table expression or CTE. Basically, what it does is we use with clause. We first use with customer sales. This is the name of the table as, and then select customer key, some sales amount as total spent from fact internet sales group by customer key, and then from that we select static case when to we have this raw data. Basically we accumulate the raw data in this table, and then from that we select summarized according to our requirement gold and VIP customers. So let's run the total above statement. If you run this, you see the all these are details in group by, but we don't have a case statement here. This is just a simple select statement, but we packed it into the with clause, and then with the with clause it holds the results, interim results, for further summarization and formatting into select from, when we can select from the interim table and make our report. So if we run complete, so we have that. So let's go to the next one, KPI engineering. Revenue 3.1 revenue KPI and profit margin. Revenue KPI. Revenue KPI means select some sales amount as total revenue from fact internet sales. We will run this one because our management wants to know what are the total revenues, so we can do that. So total revenue is this summarized, and then we have this sum revenue. Now we can also calculate the profit margin. In the profit margin, what we are doing is some sales amount as revenue, some total product cost as total cost, some sales amount minus total product cost as profit, right? And then we basically, to summarize the cost, summarize the sales amount, and then we another comma, after that comma we summarize sum of sales amount divided by some sales amount into 100. So let's run this one. You see now we have total revenue is total 22,935,8,677 total revenue, total cost, total profit. So total revenue is sales amount, sum of total product cost at total cost, and then sum of sales amount minus total product cost as profit. And then we in the third we calculated the sum sales amount minus product cost divided by total sales amount into 100. So 41.414 is the profit margin. Right? Let's go. I hope all these things are making sense. I will provide the link to this tutorial and you can practice. Average order value. So here again we will summarize. Let's run that. Average order value is 1061. Right. Now let's go to the module enterprise joint strategy, revenue by country. So here we will use some joins to further enhance the power of SQL, and we'll explain what we have done. Let's use that. So what we are doing here is basically when the joins are used when the data is stored in different tables, but they are related to each other through foreign keys and primary keys. For that, we have already created this project on these joins in the Microsoft Access as well, and we will explain also here. So here we are selecting G dot English country region name as country. So G is basically geography. We are using G to denote geography. You see we have a geography table here. Dim geography. This is the geography table, right? So we are getting English country name from this table. You see, country region, English country name from this table, right? And then we are summarizing fact sales amount. So sales amount is not in the geography table. Sales amount is in the fact internet sales. Fact internet sales. You see, sales amount is here. So we want to show sales amount also from internet sales, total revenue from fact internet sales F, right? And now what we will do is we will use the word join dim customer C on fact internet sales customer key is equal to customer customer key. You see, both of these are common. In the fact internet sales, we have a customer key, and then we have a customer table where we have the customer key, and these should be equal. When we are running the tabular data, these should be same, right? We'll see when we'll run this query, and then join geography G on C dot customer geography is equal to G dot customer geography key. So if we go to the customers table, we have a geography key, which is a foreign key from the geography table, right? So customer f dot join customer key on this, and then join geography G on here. Here we join the customer table with the fact internet sales, right? And here we join the customer dim geography to the customers table, because both have foreign and primary keys, and on C dot customer key is equal to G dot geography key group by, because we are summarizing the data, so we should group by English country region name, right? So basically we are extracting data from geography table and fact table, but we cannot directly link fact internet sales to the geography table because we don't have both primary key and foreign key. But instead we have a customer table which has a primary key and foreign key in the fact table and geography table. So we join, that's why we join that, and now run that. You see, now in the United States we have this revenue, in France, Germany, Canada, right? That's how we run this query. Now let's go to the next one, revenue by product category. Here we will revenue by product category. We will copy that. And again, here we are using joins. Basically what we are using is PC English product category name as category, some fact internet sales as total revenue, from fact internet sales F is basically we are using F as to denote fact internet sales. So join dim product. So here we are joining the product table on fact, because fact table has a product key is equal to P dot product key, right? Product key. Join dim product subcategory as PS as on product table has a subcategory key as well as product subcategory has a product subcategory table has a product subcategory key. So we're joining that. Then we joined a dim product category, basically product does not have the product category key but has a product subcategory key. So now we are joining dim product category PC on product subcategory is equal to PC dot product category key. Group by product English name, product PC product category dot English product category name, and order by total revenue. So we'll run this one. Viewers, I will also explain this specific query using in a visual way, in a visual sense. Let's do that. Uh, right, we can design a query in query editor. Just to explain what I have done here, we will use the category table. We will use the fact internet sales table, dim product category table, dim product table, and dim. Basically, these are the table we have now. You see, viewers, we will get the same results and we will add one more table. Dim product category. Okay, so basically, you see, the reason for doing all this exercise is to explain you what we have when we write the SQL code. It did the same thing which we are viewing in a visual way. So here we are selecting product category and total revenue. Total revenue is basically sales amount. So that's what we have done. The designer. In fact, internet sales. So now this it has written a complete code, what we have done, and let's copy this code. Let's do that one more time. Sorry, we basically will and here we'll use the sales amount by product category. Okay, so now you see we have all these and English product category name, but now what want to do is we want to summarize that. Sum, we will just simply write sum, and then we need to add a group by clause because we are using the product category. We'll copy that and we use that here. You see, we have the same results. The reason for explaining is visual explanation is that how we utilize uh, the tables. Let's go back. You see, our query was like this. This done the same purpose. So the goal of explaining this visually is that we have a feature here, query, design query in editor. Also, we can write a SQL. By both ways we can do that, but learning SQL is the main goal of this tutorial. So let's go back and go to the next one. Windows functions, top 10 customers. Top 10, top 10 customers with, again, we will use a common table expression here. And in this common table expression, we will extract customer revenue as select customer key, sum, sales amount as total revenue from fact internet sales group by customer key, right? Because here we are not joining any table, we are just extracting the customer key which is already in the fact internet sales, right? This table. And we are selecting top 10 customers, rank. So rank is a Windows function over order by total revenue. So it will rank total revenue descending as revenue rank, right? Let's run that. You see here we have a customer key and then we have a total revenues. So the highest customer is 10. See, we can also write down by ascending order. Okay. So we are using a rank function. We will use smallest to the highest values. Okay, then we will go to the next query, running total by year. So here what it does is select d dot calendar year's date because calendar year is available in the dates table. Dimension date, you see in the column, year, fiscal year, calendar year. So we are using calendar year. Some fact internet sales amount as yearly revenue. Some sales amount over order by t dot calendar year as running total. So what we're doing is sum over order by calendar year as a running total. So basically what it will do is this command, when we are using over sum and then order by calendar year as a running total from fact internet sales, join dim date d, basically it's a join on fact order key, order date key is equal to d date key. So basically we are joining these two tables together and group by calendar year, ordered by calendar year. So in the 2010 we have revenue of 43421, and in 2011 we have a revenue of 70,000. So this aggregated to the previous one. That's the similar we do it in the Excel. So let me show you one more thing. If we remove this clause, let's remove that and then run. You see, now if we run that, we will not have any aggregation from the previous ones, right? That was the reason I'm showing you is what difference we have by the over clause. Let's do undo what we have done. Okay. So what we do is first we have a sum of sales amount and then we aggregate this sales amount over years. So it will basically run in a running total. In a way, it shows in a running total. So that's how we have. Now we'll run that. So that's how we have a total sales in the running. Now let's go to the month over month growth. We'll use this query. Go to the SQL. So let's examine this one. Select D dot if we run the first query. So what it does is giving us the revenue of months of different years, right? But when we use the with query, we store this result in this upper portion, and then we selected this so percentage change comes here is 423 because this will minus this and then give us the change month over month change is and then this will minus this. Let's calculate that. Just to explain what it does. So let's look into that, what the lag function does. It's always good to see what it does. Yeah, basically what it does is function is a Windows function that allows you to access data from the previous row in the same result set without using self join. It is primarily used for comparing current values to the prior ones, such as tracking changes over time in the series data. So basically what we will do is we'll close that. So its monthly revenue is basically it's uh, it's checking the rows from the previous ones. Basically what we will do is we minus this to this, then we got this one. Then when we minus this from this, we got this one, month over month changes, and that's how it works. So yes, let's go to the next one. It's always because you know the goal is for this tutorial is to enhance the understanding of SQL, as well as most important is doing the practice and understanding and running on a different data sets. But in this we are using AdventureWorks. So let's go to the time intelligence function, over year growth. So here we will use a lag revenue over order by calendar year. The main purpose of this tutorial is to show you the practicality of the SQL. Let's do that. You see here we will, when this minus this, so what it does, let's go to the, that's again we use the common table expression where we store the interim results with year sales select calendar year sum fact sales amount as revenue from fact internet sales. We joined the dim date on order key and group by calendar year. So if we run this simple query, we will get the result of monthly yearly revenues, and this is stored in this table, and then we selected this select from the above result set revenue minus lag as we explained that it's previous row over order calendar year in the calendar year as year of year change, and then lag minus this over ordered by this divided by revenue minus lag divided by lag over ordered. So basically it's a percentage we're calculating what is the difference, and then the percentage of that difference to the previous ones. Let's move to the next one. Module 7, data validation and reconciliation. So viewers, this is very important aspect. Let's go there. because where if we run this data validation is a very important part, because we could have a duplicate with a small typo error and anything, we can have a different values. So let's do that first. Let's copy all of that. Uh, so what we are doing here is basically, first we calculate the sales amount without any join, right? Revenue after join. So here now in the next we use the same revenue summarize, but by joining some effect sales as joined revenue from fact internet sales F join dim customer C on customer C's on fact internet's customer key is equal to C dot customer key. So basically we will first calculate the sales amount overall, and then we also join by joining this just to verify that we are not making any mistake. So that is called data verification. Validate reconcile means reconciling validate revenue after join. If number differs, investigate the duplication, right? Here we will create a view. Module 8 in this we will create a executive view creation. BI layer. Now we'll create a view. We'll explain what it is. We will create a create view VW executive sales KPI as basically, the query when we're running the simple SQL statements, these are only for the time being runtime. When we use these will not store anywhere. These are just to view the data. But when we want to specifically store that SQL so that we can utilize that in future reports or anywhere, we can create a view, right? View is a temporary table. View is not a table, but it could basically aggregate it collects the data from materialized table where the data stored and in this logic. So here we are creating a view executive sales select sum D dot calendar year G dot English country region name as country and some F dot total product cost as total cost in some fields. These are simple measures from the fact table. First we selected the calendar year from the date table, region country from the geography table, and then we summarize these measures, and then sales amount minus total product cost is equal to profit from fact internet sales F join dim date D on, and this is the same as we mentioned before, and group by, because this is summarized, so we want to see the calendar year in the region. So let's run that. So this view has been now created. You see, let's see the view. VW executive sales KPI. So let's go to our view section. You see, these are the table section in the SQL, and these are the view section. Executive KPI, right? So it has been stored like a table under the views category. So we can run and we can select top 1000 rows. So now we can always use this in a different places like Power BI, or even we can use the SQL language, SQL also in Power BI, but sometime we want to have some specific requirements to create a view. So we have created the view, and then in this calendar year, country, revenue, cost, profit, right? Okay, so let's go to the next one. Module performance optimization. So that's a very important aspect of the running SQL part. And in this, we will say here, avoid select static. It's always a bad practice when we just put the static from that basically will bring all the rows from fact internet sales, which is not a good practice. It will affect the performance, more load on the databases. So better one would be we will mention specifically what columns we are looking for. So select sales amount, order key, customer key from fact internet sales. Module 10, capstone executive query. So here what we are doing is top 5% customers by revenue. Let's run that and we will explain what it is. So here again we are using common table expression. We will store our interim results, and let's run. Okay, which you see with this use here we are using two common table expressions, and as with will only be used once first. It's very important point here to be mention. I would like to mention here first we store this result with customer revenue as select customer city sum sales amount as revenue from fact internet sales group by customers keys, and then comma ranked customers. Let's run this one. Okay, basically what we did is we are using two common table expressions. First, we store our result as fact internet sales group by customer key, right? Let's run that. We revenues, total revenues, and then you see there are a lot of customers here. So let's explain what is entire function. because that's important aspect we want to have our viewers know. Entile in SQL Server. Let's see that. So basically, we will use, we are constrained to use this, uh, the query we have already created. We can further investigate that. Entile SQL exampl example. So here we will explain you what the entire function does. Example. Let's run this. So let's go through this because this is basically the focused on the entire function. So we are using AdventureWorks and select first name, last name, entire for over. So we use these into four categories of these result set. Okay. And we'll go back to our example which we have done, and then let's run that again. So we have to DW2. Okay. So here we use the entire function, and we selected, and in the last para we selected those with the one value, with the top of these, right? Okay, so let's move to the next one. Yeah, that was the last one. We'll just do the practice and research on these entire functions. The goal of this basically tutorial is to show very important functions which are uh, frequently used in understanding the data, and maybe we're required to run queries. And some are simple and some are bit advanced, but the practice will make more practice you have, the more understanding you will get. So that's it for today's tutorial. So see you next time with new projects and new tutorials. Thank you and have a great day. And if viewers, if you like our channel, please subscribe and also like the video.